Hello again. Today we're going to be talking about natural logarithms. We've talked about the natural exponential, so now we're going to talk about the inverse of that, which would be the natural logarithm. So remember, we talked about log of x, which means log base 10 of x. So another base that gets used very, very frequently is that number e that we talked about, 2.7182818. It keeps going just like pi does, but that base gets used very often in natural situations. So we can't write it as log x because that's already being used for base 10. So if we want to talk about a logarithm base e, we're going to use that ln notation, which means natural logarithm. It's actually from the French, so that's why the letters are reversed, but just know that ln means the natural logarithm. So it is the inverse of e to the x. So if I wanted the natural logarithm of e to the 5, that natural log and the e would cancel each other out, and I would get 5. Similarly, the natural log of e to the 38 would just be 38. And if I reverse the order of those and I did the e part first, then e to the natural log of 7 would be 7. E to the natural log of 29 would just be 29. So I just want you to understand that relationship of when we can cancel things out, because that's how we're actually going to be able to solve equations that have natural logarithms in them and natural exponentials in them. You would probably need a calculator almost always to find a natural logarithm, unless it was one of those cases where things canceled out nicely. So the natural log of 6 is a weird decimal. The natural log of 100 is a weird decimal. So chances are, if you have a natural log question, you need a calculator in front of you. So let's look at an application. We have an investor who deposited $1,000 into an account at 6% compounded continuously. And we've talked about that equation for continuous compounding interest. So we want to know how long it will take the investment to double and be worth $2,000. So there's my formula there, A equals P times e to the RT. Now in this case, I don't know t. That's my missing piece of information. It's not like I'm trying to figure out the value of A. I need to figure out the value of t, which is on the right-hand side. So I'm going to have to solve an equation. I'm going to replace A with 2,000, P with 1,000, and R with 0.06. So I'm replacing those values there. The first thing I'm going to do to solve for t is divide both sides by 1,000. So I get 2 equals e to the 0.06 t. So now I run into problems because I need to get rid of that e. But we've already talked about how to get rid of e. The opposite of e to the something is the natural logarithm. So I'm going to apply that to both sides. The natural log of 2 will equal the natural log of e to the 0.06. And as we discussed before, if I have the natural log of e to the something, that simplifies to just be the exponent. So the natural log of 2, which my calculator says is that weird decimal, equals just 0.06 t. And so if I divide both sides by that 0.06, I'm going to get that t equals 11.552. And so what that means in terms of the problem is it will take 11.552 years. Now notice that I am writing the time as a decimal because the interest is compounded continuously. So it's not like I would have to round to the nearest year or the nearest month. It's continuous, so saying that it will take 11.552 years is reasonable. So that is the natural logarithm and one way that it can be applied to a real world problem. If you have any questions, please let me know, and I will see you tomorrow.